Okay, so we've dealt with the practice problem for example 1. So now let's go to example 2. Now this one says to solve cosine squared x minus cosine x plus 1 equals sine squared x for x being between 0 and 2 pi. So for this one, it doesn't deal with principal values. It doesn't say actual principal values here. It says to find the values for this function or for this equation. Now make this true. That's between 0 and 2 pi. So it means there could be more than one answer. There could actually be 3 answers in some cases. So with this one, you have to figure out what's going on. Alright, so we're going to solve this out, and we're going to try to get this down to 1 trig function or possibly 2 at the very latest, at the very bottom. So we have to break all this down to get down to 1 trig function at the bottom or 2 trig functions at the bottom. So I'm going to pull this out. Not sine, but cosine. So it says solve this out. So we're doing cosine squared x minus cosine x plus 1 equals sine squared x. Alright, so with this, the best thing to do is to think of any trig identities here that has sine in it or cosine in it. And what would be the easiest and the best thing to do is to get everything to be either all cosines or all sines. So it'd be a little bit easier to work with when we have to either factor it down or break things down to get parentheses and all the good stuff, just like a regular algebraic expression. You'll do that here. You'll break it down to get everything down to x's and y's or all x's or something of that sort. So in this case, that's what we're going to do. We're going to break this down, and we're going to try to get everything to all cosines. Because we have 2 cosines here already. So maybe if we can change that to cosine, we'll get everything all cosines and not have to do with so much work. So let's take a look at that. We know here, by doing this so many times in class already, that sine squared x equals, what is that? Is it 1 minus or 1 plus? And we say that's 1 minus cosine squared x. And that's using the Pythagorean identities and moving it around and manipulating them until we get to sine squared equals something. And that does with 1 minus cosine squared. So, by doing that, we're going to substitute 1 minus cosine squared into this function right here. So instead of writing sine squared, we'll do equals 1 minus cosine squared x. Alright, and then we're going to pull everything else down. We're going to erase this because we already know that one already. We already know that identity, or that manipulation of the identity. So we're going to go ahead and solve this out, getting like a value on one side, or a number on one side, and then getting everything else to the other side. So what we're going to do, we're going to move cosine squared over to the other side. We're going to combine that with the cosine squared that's already on this left side here. So we add cosine squared to both sides. So that cancels, so we just left with the 1 there. And now on this side, we get 2 cosine squared x minus cosine x plus 1 equals 1. Alright, so let's move that 1 over also. That way we can kind of get equal to 0. So if we do that, we'll go ahead and subtract 1 from both sides. That cancels, and that cancels. So it makes it a little bit easier for us to work with, not hard. So we bring everything down, and we set it equal to 0. And from there, we go ahead and solve it out. So, once again, like we did on the last problem, we looked at what they had in common and pulled out what they had. In this case, we can do that again. So we're going to pull out what they have in common at this point. Can't do it up here because there's actually 3 terms and they're all married together. We can't do it up there, but because there's only 2 terms here and they have the same thing in common, we can pull it out. So remember, once again, 3 terms, can't pull something out of these 2, but it's not in there. But with 2 terms, if they have the same thing in common, we can pull something out. So that's what we're going to do. We're going to pull out a cosine x. So this was 2 cosine x minus 1. That's going to equal 0. And so once again, we're back down to the 0 product principle. so we do cosine x equals 0. We'll do 2 cosine x minus 1 equals 0. So here we have cosine x equals 0. That stays there. And then for this side, we go ahead and move that 1 over. So I guess we'll say positive 1. Divide by 2. So that gives us cosine x equals 1 over 2. All right. So we solved it out. We got cosine x equals 0. We have cosine x equals 1/2. But they're asking for us all the values between 0 and 2 pi that would give us 0. And all the values between 0 and 2 pi that would give us 1/2 for cosine. So going back to our chart and our graphs and all the good stuff again from chapter 6 for this one, because it's radians, we need to find where they are. And as we said in class before, that was pi and 3 pi over 2 for cosine being 0. And then for the other one, we're looking at pi over 3 and 5 pi over 3. So it's requiring you to remember that table, that chart, everything that we've done. It requires you to remember all that information. And so these are our 2 answers, or these are our 4 answers for this whole thing. Make this whole thing true. So no matter what, if you put in pi over 2 in for x and solve the problem out, that would, both sides will equal each other at the beginning. 3 pi over 2, pi over 3, and 5 pi over 3. If you put each one of those individually in there, so we put all pi over 2's into the original function. So into this function here, if we put pi over 2 there, pi over 2, and pi over 2 here, we solve that out, we will get that will equal each other. If we do 3 pi over 2 here, here, and here, it will equal each other. If you do pi over 3 in all 3 of those spots, it will equal. And if you do 5 pi over 3 in all 3 of those spots, it will equal each other again. So, not hard, not bad. Okay. But it's requiring you, once again, to remember your algebra skills and what you did to solve things in algebra. So, with that being said, we're going to go to a practice problem again. And this is one I want you guys to work on. We're going to look at sine squared x minus sine x plus 1 equals cosine squared x this time. This is for x being between 0 and 2 pi again. So it's kind of like what we exactly just did. And it's kind of almost the exact same way we set it up. But instead of it being cosines over here and sines over here, you have sines and then a cosine there. So you have to think about how to solve this out without me giving you any hints or any help or anything. You got to think about this and see what we did on the last one and see how it fits with this one. All right, with that being said, go ahead and work on it. And let's see. Yep, go ahead and work on that. And yeah, don't worry about it. Yeah, go and work on it.